So in the last video in this playlist, we learned about async-let. That literally let us perform multiple asynchronous functions at the same time. But the question came up, of course, what if we have a whole bunch of asynchronous functions that we need to run, like maybe 10 or 20? Async-let isn't super scalable. How can we run a whole bunch, a group of tasks at the same time concurrently? And the way to do that in async await is using a task group. It's literally a group of tasks, and we are going to, in each task, we're going to put in a method to download whatever we need to download. They're all going to execute at the same time concurrently. We're going to wait for all their results together, and then we're going to return that back to our app. So very similar to what we did in the last video, except this is probably a little bit more scalable, but as I'll point out at the end, there is a slightly different use case here. In the task groups, we are fetching one single return type. In the async-let, we can do different methods returning different types. This is probably one of the most underrated APIs that have come out of Apple in the last year. If you compare using a task group to not using a task group, like if you were to perform all of these functions in like a for each loop rather than using a task group, the download time in your app would literally like quadruple. This saves an incredible amount of time, not only for you as a developer because it's easy to code, but for the performance of your app because it downloads all this data concurrently super fast.
All right, welcome back everyone. We are back in our Xcode project. In the last video, we took a look at async-let, and we figured out how we can run multiple asynchronous functions at the same time in a single task. But we did run into one issue, and it was that this wasn't super scalable. For each function that we had to run, we had to write more code. But thankfully, Apple has actually given us something called a task group, in which we can create a single group of tasks and run a whole bunch of tasks concurrently. So that's what we're going to do in this video. A lot of the screen and the setup is going to be the exact same from the last video. So if you were with me in the last video, we're going to do some copy and pasting. If you were not with me, I'll give you a chance to catch up. But let's start by right-clicking the navigator, creating a new file, a SwiftUI view, and call this TaskGroup Bootcamp. I'm going to set up the screen very similar to what we did in the last video. So it's going to be a navigation view, a scroll view, a lazy V grid with an image and a title on it. I'm just going to copy that, put that in our new view here. I think I need it closing brackets. The difference we're going to do in this time, we're going to actually create a view model for the view. So let's create a class, call it TaskGroup Bootcamp View Model. Let's conform to observable object, and let's initialize one in our view. Then at state object private var view model, set it equal to TaskGroup Bootcamp View Model. Now we need columns, so let's go back to what we did in the last video and paste the columns into our view here. We also need images that we want to loop on. So in the last video, we did an at state private var images, but in this video, we're going to put them in the view model. So it will be at published instead. Our for each will then reference view model.images. Let's change the navigation title to task group. And we are almost done with the setup already. Images should not be private. Let's get the canvas working here. Task group, I'm loving it. And let's simulate again like we're in an actual application. So in a real app, we're going to have our view, we're going to have our view model, and our view model is going to reference some sort of data manager where we're getting all of our data from. So I'm going to create another class up here and call it Task Group Bootcamp. Let's call it Data Manager. And we will open the brackets here. Let's get a reference to the data manager in our view model. We'll say let manager equals that. Again, normally we want to inject this, but we're not worrying about that in this video. And then in here, let's create some functions to fetch images, just like we did in the last video. So I'm going to go to the code in the last video and again, copy our fetch image code, come back out here and paste it into our manager. So this is a very basic function to fetch an image from a URL. The only difference is this time let's pass in the URL. So here we'll say URL string of type string, and then we will first convert that from a URL string to an actual URL. So we'll say guard let URL equals a URL from string, the string being our URL string, and we'll say else. We'll just throw a URL error dot bad URL. All right. I don't think we're going to run into this error, but we're being safe coders here. So we have our fetch image function that's then going to try to fetch a UI image. Now, before we actually get into TaskGroup, let's review a little bit of async-let that we did in the last video. So this fetch image function, I'm actually going to make it private, so we can only call it from inside this manager. And we're going to create a separate function called fetch images. Let's call it with async-let. Open close parentheses, open the brackets. This is going to be an asynchronous function that returns us an array of UI image. And we learned in the last video how to use async-let. I would challenge you guys, if you want to pause this video right now, in this function, try to use async-let to call this fetch image 4 times and then return that array of 4 images back. So go ahead and pause and try that. If you don't want to pause it, I'm going to do it real quick. So async-let will say fetch image 1. We'll set it equal to fetch image, and we need a URL string. So I'm going to use the URL that we actually did in the last video here. I'm just going to paste in that string. And the reason I put the URL string as a parameter here is because realistically in your application, every time you fetch an image or you fetch some data, you're probably going to have either a key or an ID or a URL string to actually fetch from. So it's kind of just a little more of a realistic simulation. But of course, we're just going to use the same URL for all of our fetches. So let's do 4 of these. Fetch image 2, 3, 4. We're going to say let image 1, image 2, image 3, image 4, and we'll set it equal to await. We're going to wait for all 4 of these together. So fetch image 1, fetch image 2, fetch image 3, and fetch image 4. Now we know all of these can throw, so we actually need to mark them with the try keyword. And lastly, we want to actually mark the entire function as a function that throws errors. Because when we try to do these, we might throw errors, but if we do get these, let's then return them back to the app. So we will return an array of UI image with image 1, image 2, image 3, and image 4. All right, let's call this from our view. So coming down here, in our view model, we'll create a func called getImages. This will be an asynchronous function. We'll say let images equals manager dot fetch images with async-let. This is an asynchronous function that throws and can return a UI image. Now we don't care about the error if it throws back, so we are going to try and we're going to make it optional so that we don't actually need to deal with the error. Of course, we need to await on the result because that is an asynchronous function. And very simply, we're going to say if let images. So if we do get them back, we'll call self.images.append the content of the images that were returned. Really cool stuff, guys. I know there's a lot of duplication here across these videos, but this was, I think, the easiest way to explain it all to you. So in this scroll view, let's create a task. Learn tasks a couple videos back. Task opens us into an asynchronous context, and then we can call asynchronous functions like this one. So we can call await viewModel dot get images. Let's click resume on the canvas here and see if it works. Press play. Bang. I should have made it harder. That worked way too fast. It looked awesome. And now we need to talk about TaskGroup, of course. So this is great if we want to fetch a couple different requests. But you could imagine that if this number of 4 fetches went to 10 or 20 or 50, this is not very scalable, and there's got to be a better way to write and perform multiple concurrent asynchronous requests. And the way we do that again is with a task group. So down here, let's create another func and let's call it fetch images with task group. Open close parentheses, open the brackets. Just like this function, that is an asynchronous function that throws and returns an array of UI image, so is this one. The difference, though, of course, is going to be the code inside. What we're going to do is actually start typing task group, and we can see that there are a couple different options here for task groups. The main difference that you're going to see are some say with task group, some say with throwing task group. And the only difference there is whether or not the function that we're calling, which is going to be fetch image, needs to throw back an error. So if we want to throw the errors out of the task group, we're going to use with throwing task group. If these functions don't throw errors, and they're never going to throw an error, we can just use with task group. But of course, our function here does throw errors, so we're going to do with throwing task group. I'm going to use this first completion here, and we can see that the first parameter we need to include is the child task result.type. So basically inside this task group are going to be a bunch of child tasks, and those tasks need to return a specific type of data. Now we know already that all of our child tasks are going to be calling fetch image, which is returning a UI image. So the child task result type is a UI image, and we're going to call .self referencing the type UI image. Now the body, this looks complicated, but really we can just press enter and call this group. So this is the task group, and right now it's an empty task group. It doesn't have any actual tasks in it. But what we can see already is that this with throwing task group is an asynchronous function. So just like any other asynchronous function, especially any asynchronous function that throws, we need to try to fetch it, and we need to await the response. Now what we know inside this task group is that we need to run a bunch of child tasks that fetch UI images, and then we want to return an array of UI images. So what we're going to do is create a blank array to start. We'll say var images of type array of UI image. We'll set it equal to a blank array. And then at the bottom of our function, we will return images. So we're going to return images out of this function, and then we want to return them back out of this function. So we will return here, and this is returning the result of this function back out of this function. All right, so now we have this blank task group here, and in this group we want to add a bunch of tasks. So we're going to say group.add_task, and we can see add task pops right up here. We can set the priority, and then we can do a asynchronous operation. Now these are child tasks of the parent task that we're going to be inside, right? So when we call these functions, we're already coming from a task on the view, and when you create child tasks, they're going to inherit the priority of the parent task. So oftentimes we don't actually need to set an explicit priority here unless you really want to. But the key thing to note is that the operation, we'll notice, is a asynchronous function that throws and returns an image. And the reason it returns an image is because we declared at the top here that this is a task group of UI image. If this was a string and we went to call group.addTask, we'll see that is an asynchronous function that returns a string. So again, this is just another example of how the compiler is really helping us out in these situations, telling us exactly what kind of operation we need to add to this group of tasks. So I'm going to call group.addTask and open the brackets. I'm not going to set a priority, but we know the operation in here needs to be a function that returns a UI image. So we already have that function. Let's call fetch image with a URL string, and we'll pass in our URL string. This function is asynchronous and it throws, so we want to try await the result here. We are getting a quick error here that we need to require an explicit use of self because we're in a class and we're doing asynchronous code, so we're going to create a strong reference to the class. So we'll just leave a strong reference to self for now, not the worry of this video. So what we're going to do is basically, to our task group, add a bunch of tasks. So that's one task, this is a second, a third, and a fourth task. So now we've added a bunch of tasks to the group, but we want to now await all of the results of all of those tasks. So just like we did up here where we wanted to wait for each of those calls, now we want to await the result of all of these. And so the way we do that in a task group, we can say for, let's call this task result in the group. Now we know all of these tasks are asynchronous functions that can throw. So when we get this error here, this error looks super confusing. It requires that throwing task group conforms to sequence. That's probably not the right error that would be thrown here. What the real problem is that this for loop really should be asynchronous. It should be waiting for the result of all of these. So the way we can declare that is actually by saying for try await each result in the group. So we are going to wait for each result to come back. The beauty of this is that we are waiting for the results in the group, but we are not necessarily waiting for them to come back in a specific order. So we're adding a bunch of tasks and then just waiting for all of the tasks that come back. It doesn't matter which one's coming first. Whatever one comes through is going to come through this loop. And as we get these results, which we can see is of type UI image, we can then call images, which is our image array here, and dot append the task result. It's probably more explicit here to actually call this for await image in group, and then this will be images.append image. Now it's important to note that this for loop, it's not like a regular for loop where it's going to iterate over the loop immediately every time. This for loop is going to wait for each of these tasks to come back. So if theoretically we were to run 4 tasks and let's just say one of them never returned back to our application, we would be waiting for that last task forever, or until it fails. That's just something to be aware of when we're using these for await loops. And before we go and edit this, let's see if it actually works. So I'm going to, we append all of these images. After we get all of the images back, we then return them back out to our application. So I'm going to come down here and in our get images function, let's call manager dot fetch images with async task group. Let's click resume on the canvas here. Let's click resume on the canvas here, press play, and just like that, it worked perfectly. Sometimes I wish we actually ran into errors because then we could do some debugging. But Swift concurrency takes out all the errors for us because Swift is now such a type-safe language. We got to add all of our keywords everywhere, and we run into very few errors. I think this is awesome. And the next thing we want to do here is basically, normally we don't want to add all of these tasks manually. So I added 4 tasks here just to show you guys that we are adding a bunch of child tasks to the group. But realistically, the reason for using this throwing task group is that we can add a whole bunch of tasks without having to manually add each one. And the way we do that is by having something to loop on, and then we add tasks as we loop on that. So what we're going to do is actually create an array. Let's up here create let URL strings and make it an array of strings. And up here I'm just going to paste in our URL. And I'm going to copy and paste it a couple times here. Let's do 5. I think there is a limit on how many times you can hit this API, at least like within a couple seconds or minutes. So this array we can add as many as we want, but I think this API we should keep it pretty low, maybe less than 10. But anyway, what we're going to do then is then loop on these strings. So we'll say for URL string in URL strings, open the brackets, and then for each string, we're going to add a task. So group.add task, and we will then call our try await fetch image, and we're going to fetch on the URL string that we're looping on. I'm then going to delete all of these add tasks down here, and we can start to see just how short our function is and how scalable this could then be, right? Because now all we need to do is update our array basically, and then we can get a whole bunch of images on the screen. This is a little more realistic in your app. Oftentimes if you have to fetch a whole bunch of images or a whole bunch of data points, they're all gonna have IDs, so you'd probably just pass that in as a parameter to this function for image IDs, and then you would make a bunch of your async, and then you would add all of your tasks here. But for our purposes, you can see, once you have this set up, now we can asynchronously add a whole bunch of tasks to this group, await the result of all of these tasks, and then return back to our app. A couple quick notes before we end this video. Firstly, this images array here, more often than not in Swift and in any programming language, when you create an array, you have no idea how many items are going to be added to that array. And when we create our empty array here, the compiler has no idea yet either. But we know as developers in this specific instance that this image array is basically going to be filled with the same number of images as URLs that are in this array, right? So we can actually add a slight performance boost here to basically tell the compiler exactly how much space to reserve in memory for this array. So here we'll add images.reserve capacity. We're going to set the reserve capacity, which literally is reserving enough space to store the specified number of elements, I believe, in memory. So all we need to do is add a number of elements that we're going to add to this image, and that's going to be URL strings.count. This is just a very slight performance boost. I've seen it in a ton of tutorials for throwing TaskGroup and TaskGroup. So this is probably one of the better places in our code to actually use this. And the last thing I want to note is that this try keyword we are now becoming super familiar with. But if you've been following this playlist, you are now well aware that if one try were to throw an error inside a task, the entire task throws an error and stops running. And so it's really important to think about that when we're doing these throwing task groups, these tasks with a whole bunch of different fetch requests. Because in this case, if we are fetching maybe 50 images, right, we could get 49 images perfect, but if the last one fails and throws an error, we're going to throw an error back to the application. Even if we got 49 successfully, we're still going to throw that error if one single try throws an error. So oftentimes I find that I like to make the tries inside these task groups optional. So this way, if one of them fails, it's just going to return a nil value rather than failing the entire task. Now that's kind of a developer call that you have to make when you're adding this code, but we'll make it optional, and that means the type of task, and that means the result of this child task is no longer a UI image, but an optional UI image. And that finally then means that when we get these images back, they are going to be optional. So in here, we're going to say if let image equals image, and then we will append it. So now there's a chance in my app, if we are fetching 5 images, but only 4 are successful, we'll still return that array back, except it's only going to have 4 images and not 5. That's again more of a case-by-case situation. I just wanted you guys to be aware of that. And now you guys are absolutely experts on task groups. Again, there's throwing task group for child tasks that actually throw errors. There's also with task group if you don't have functions that are actually throwing and are just running asynchronous code. And again, we are creating our array here, but realistically in your app, you'll probably pass that in as a parameter to this function. And with that done, you can see just how condensed our code is for fetching 50 different images. We can literally just use this code. And regardless of what type we are returning, the setup is more or less going to be the same. You create an array for whatever type you're going to get. You loop on all of your data points and add tasks for each fetch request that you want. You await the result of all of those requests. And then after you're done and all of those requests come back, you then return back to your application. So we are running right now, we are running 5 asynchronous fetch requests concurrently at the exact same time. And again, these are child tasks of the task that we are in. So all of these tasks are inheriting the metadata from the parent tasks. So for example, if the parent task had a high priority, so would all of these child tasks, unless we added our own custom priority here. But more often than not, we don't really need to do that. All right, you guys are now experts, but we still got a lot to go. Hope you enjoyed this video. As always, I'm Nick. This is Swiftful Thinking, and I'll see you in the next video.